should be running now.
So the experiment 2 challenge question is, suppose you are a malicious actor in the energy market and just want to see the world burn. What would you do to take advantage of the way the D3A has implemented energy markets to break the market? So the types of things that we were talking about earlier with if you're trying to take advantage of privacy and like private information, for example, how might you use that information, or what information would you use? So kind of go through your process of how you would try and destroy the energy market, the energy grid. And same thing, work in that free space would be great, and we'll discuss it at the end.
Yeah, basically try to be Enron.
Simulation finished. All right. Great stuff. Great. So let's go through the interesting results. And instead of voting on them first, we'll just go through them here. But we'll probably do a voting feature again tomorrow. But there's a couple ones for this one, as we were fixing some issues a lot of the time. So the first one here, community A is selling more than buying. This shows how the solar resource increased from experiment 1. Could whoever posts this one talk about it?
Yeah, I posted that one. Yeah, you basically can just see a lot of exports from community A, and this is mostly just from the solar that's being sold. Well, it's the community A market, so the solar is either being sold to community B or back to the grid. And if we compare this with experiment 1, we have a lot less exports, and it's just because of the solar resource.
Great.
So I think it's just sort of evidence of the seasonality. You know, we picked March, and so this is the second week of March. It's becoming a bit sunnier, and as we do further research, you know, we'll see different seasonal patterns.
Wonderful.
Good.
Okay. Next one, experiment 2 on the left, the basement line on the right. I think, Chris, did you put this one?
I also posted that one. Yeah, I was just looking at community B, because this is the normal or dumb community that's just buying. So, yeah, the left is experiment 2 and the right is the baseline. So, I mean, you can see they're both gaining a benefit from being able to buy from community A, but on the left, you can see there's a little bit more price variation. So instead of just having a max and min price, there's more trades that are happening between the minimum and the maximum. And I posted this while the simulation is running, and so now I could actually go and look at the total bill for community B and see if that's actually more or less than the baseline. And I mean, the baseline I'm using here is the one where we had 4 cents grid fees, like a total of 8 cents. So since we changed the grid fees, we have to rerun the baseline, but just something that I noticed.
Cool. Yeah, great. So with the changed grid fees, that means that the sellers in community A would look first to the community B before trying to sell to the feed-in tariff, right? So that we expect there to be a little bit more benefit, which is great.
Yeah, I think so. And then I'm also wondering if maybe there's just more variation in the price because we have a diversity of strategies, which we don't have in the template strategies.
Mm-hmm. Good point. Cool. Greenlytics, you changed your strategy a little bit. Can you talk a little bit through that?
Yeah, I can explain what we have done. So we are not very satisfied with the price forecast of the last experiment. So we decided to completely take it out, and we set our price estimation at a hard-coded value. And we wanted to see with this if our bidding strategy was efficient, taking away the uncertainty and the errors from the forecast. And
Great.
I don't have any answer for now if it has been efficient or not. I haven't analyzed the result.
Okay, cool.
Fast look on the results, seems that it performs better now. But of course, it's a different week, so we have to consider that.
Mm-hmm. Yeah, I think there's a lot more PV this week, so your PV would likely do better no matter what. But I think this kind of pushes the point for we just need to experiment more. Like having 4 experiments over the course of 2 days is great. But if we get to the point where we can run these pretty consistently in a lot of different scenarios, we just need more data.
Yeah, I haven't been able to post it, but I just checked the green storage house 1, and at the end of the week, it's discharging almost fully. So either that was a change in the strategy or related to the resources, like the PV resources and load resources. So maybe that's what the team mentioned when they said that it was doing better at the end of the week.
Great. I posted something here, but I think Sarah put it in much better words here and visuals.
Yeah, let's see.
The storage is purely driven by the prices, so we don't consider the end of the horizon to have been depleted.
Okay.
Mm-hmm. Yeah, it looks like in the picture I'm looking at, which I can add to the Miro storage 1, it starts discharging and then the day ends. So I think the rest of the discharge would have happened in the early morning of the next day.
Yeah, if the prices were high, yes.
Mm-hmm.
Okay. Great. So, Sarah, did you haven't talked this one through yet? Sure.
Yeah, it's very similar to what you posted at the bottom. So I was just looking for changes in the peak imports and exports. And again, we're using, the baseline isn't exactly the same, but I think it's close. And so I noticed in the top picture, the left is the baseline case, and then the right is this experiment. And so you can see the purple line is showing what the peak export is, and there's still a gap between the purple line and the blue line. And so that's actually measured that the exports are 75% of the baseline. So they have decreased. And you can see that, in the decrease on the left, you have that blue export section, March 13th. It's pretty deep, and then it becomes shallower as we traded. And this was the end of the week, so it's kind of my understanding that everybody was trading during this time successfully. Mm-hmm. But it would be good for us to double check that and maybe try to figure out where this PV was rerouted to. But yeah, that was a positive result that I saw.
Great. All right, anything else anybody saw throughout the simulation, or any outcomes from when we were debugging some of the scripts, things like that are interesting to talk through before we get to the challenge question?
I think from my side, I'm still have some numbers that take longer to crunch. Like I was gonna see if I could compare the self-sufficiency, self-consumption, or the energy bills, but maybe we'll have more time to do that tomorrow. Great.
Yeah, bring your analytics shoes for Saturday, or analytics hat, however you model it. Because there will be, the challenge questions will be a little bit more numbers based, just as a hint. But I'm very excited to see what you all have come up with for this challenge question. So let's see how many bad apples we have here. Who would like to go first? Any of the teams? I see Oli here, so Oli, why don't you go ahead?
So with the algorithms and the trading and the grid tariffs that are in the different simulations, you would like to discharge certain parts of the grid. You want to distribute the electricity more even, so that certain connections don't get overused, or that there's no overcapacity. And you could also insert parameters or algorithms or data that does the opposite, that literally leads to bottlenecks in your electrical infrastructure.
Yes, exactly. Yes, so this is the thinking here is a multi-party interaction, and so the grid tariffs are set by the grid operators, because they have internal systems of predicting forecasting congestion. And the question is, is exactly as you say, can we enable a fully a market approach, a pure market approach to avoid congestion management? Yes, and through grid tariffs. Yes.
Maybe also from the viewpoint of the IT architecture. I mean, in the local markets we're looking at right now, basically every device will have an IP address. It's addressable from the internet. And if I have competition on a household level, building level, neighbor level, or district level, however you want to set up the local market, I am kind of incentivized to kick my competitors out of the trading, right? So maybe I will start hiring DDoS attacks in the internet to target my neighbors, right? I think this is a very interesting game theoretic aspect that should be calculated into any economic analysis.
So the point that Oli brought is also similar to what we have taught, like the energy requirement and the available energy, how do we receive these informations? So these inputs are coming from a weather forecast or a meter data or the device information. If those data are changed by a malicious actor, and if some of the market players are expecting this manipulation, then they can also benefit from this inputs.
Yeah.
So
yeah, there is some thinking into this. So the Energy Web Foundation, they're building an open source toolkit they have recently published called Decentralized Asset Registry, based on DIDs, decentralized identifiers. And this is a project they have started to do with a couple of TSOs, where in Germany we call it Stammdatenregister. And so there is also a project going on with the German Energy Agency. So it's not only a German or an Austrian project, it's also kind of in Belgium. So what this project is about, it's about an identity of an asset that can be or let's say it differently. It works in a very similar fashion like decentralized identity, where there is an asset which has an owner, and this asset is controlled by the owner, but this asset has a reputation, and this reputation is given by decentralized identifiers. For example, the installer who installed it, he certified he installed it. Then the TSO, he certified it because this asset applied to participate at a market that is run by the TSO, and so forth and so forth. So it has it's building up a reputation, and so forth. So and this asset registry is kind of decentralized, so that anyone can actually register their asset for specific market activities. Then,
was it you, Elias, that wrote the first one?
As you want.
Okay,
yes,
so the second.
I wrote it.
Yeah. Okay.
But you can comment if you want.
Maybe you can start.
Yeah, I was writing that because it's a electronic market, let's say, taking place on some server side. So it's there are always some possibility for some hacking or DDoS attack. And I was writing that this definitely will affect the energy trading part, but the power flow and the operation may be not affected. This depends on how tightly is connected the trading decisions in this platform, in the market, and the actual actions in the power system.
Yes. Yeah.
And the second part there, I just hypothesized that with being open and transparent, also has the potential risk that people will actually look in your code base for vulnerabilities and exploit them. But I don't know if there's a clear way on how you can kind of, make a kind of like, sealed chip so that you that even if there's a vulnerability that cannot, you cannot get in there and spread to other parts of the application?
Yeah, Sebastian, I think there is two answers for this. I mean, first answer is the simulation, the backend. So we do not believe we can create a market design that can be actually used on a global scale or on a national scale if it's not open source.
All right. Well, we are coming up on our 8 hours of recording time with Google Meet. Really appreciate it. It was a really wonderful day. I had so much fun. I think the questions were really insightful. I love how Miro was used, and I'm excited for us to get back into it tomorrow. I really appreciate your time. Ed, do you want to close us off with a...
Yeah. I mean, from my side, I would like, to say it might not be obvious to some of you, but what happened today is actually something groundbreaking. I mean, in the sense that, there is a lot of peer-to-peer developments going out there in the world, hardly any in collaboration like this one, and that we came together to optimize specific setups for individual bases. I haven't seen something like this before. And this opens up so many different type of business models. Just today, we had a discussion with a couple of parties in between where, we had some entities contacting us that wanted to make simulations on a whole country level. Imagine we create a digital twin of a country and put some of the assets into the library and open this up, with the bounties to anyone who optimizes it. I think for me, this was really, I mean, on the one side, of course, we were very nervous, does it work or not, and so forth. But on the other side, I think it just shows, that we can really do something as with different companies, together in one thing. And so I'm really grateful to all of your contribution and support. And you actually, you are actually our clients, so if there is a way how we can make the product better, yes, I mean, you're actually not our only clients, actually the DSOs are our clients as well. Actually, anyone in the energy market is our client, right? So now when we talk to other clients that want to run large simulations, have a lot of data, we would be happy to bounce this with you if you would be ready actually to optimize it. Yeah, so cool. I basically wanted to thank you all, and yeah, hope you can have a beer now. And yeah,
Thanks, Ed.
Yeah, you have one. Yeah, cool.
Thanks, everybody. I'll see you on Saturday, unless we have some time to talk tomorrow.